Bottleneck.
It's the bottleneck is your ability to provide oxygen. The more oxygen you can provide, the greater the bottleneck opening. The less apt you are to produce or carry oxygen to the cells, the bottleneck is small. If you are in training, and it's aerobic training, this bottleneck will come clear out to the sides, and thus you don't build up a lactic acid oxygen debt. All right? You understand that?
Mm-hmm.
All right. The things that you should subject to memory would be that glycolysis is anaerobic. Glycolysis only produces a small amount yield of ATP to net, and most of the energy is tied up in pyruvic acid because it is anaerobic, and enzymes are used. You will get, besides 2 ATPs, you will get 2 hydrogen carriers, and you get lots of pyruvic acid. Any questions on that? All right. If, as you are doing right now in this class, you're not really real active physically, so you are able to burn up pyruvic acid as fast as you form it. The pyruvic acid is picked up by acetyl-CoA, which is converted into acetyl coenzyme A, which brings the pyruvic acid into the Krebs cycle as citric acid. This is called the citric acid cycle, the TCA cycle, or the Krebs cycle. These are the different names for it. All right? The Krebs cycle will make 2 cycles per glucose process. So if you processed 1,000 glucose molecules through the Krebs cycle, you would have 2,000 turns to the Krebs cycle. The bottom line is that what you get primarily from the Krebs cycle is lots and lots and lots and lots and lots of hydrogen carriers that are fully loaded with energy, potential energy, that's got to be extracted. You also get carbon dioxide. You also get 2 molecules of ATP. And what happens to all of the hydrogen carriers there and more of the hydrogen carriers from the Krebs cycle, they all have got to be processed through this electron transport chain. And the end result of that is that you get between 32 and 34 molecules of ATP. These are oxidation reduction activities. Now, let me show you again, because this is extremely important to understand what is happening as we speak, really. You know, because I've brainwashed you, I guess, that your immediate source of energy is ATP. All right? To extract it, you have to send it through cellular respiration. All right? ATP. ATP is where you have that 3rd phosphate bond. Is very highly energized. Remember the rat trap I brought in?
Mm-hmm.
Remember? It unset, it had some energy. Remember I could put it on my hand and it wouldn't fall off. Well, to energize it, it takes a lot of my energy to push that bar over. That third phosphate's the same way. It takes a lot of energy for you to take an ADP and add a phosphate to it. That third phosphate takes a lot of energy to tie it on. That energy to tie the third phosphate onto the diphosphate comes from the hydrogen carrier electrons. So you have this highly energized hydrogen electron. It gives its energy to adding the third phosphate to the diphosphate. Thus, you have this really energy-enriched ATP molecule used for all cellular activity. The hydrogen is now all worn out. It's all poofed out. It's given up its energy. So as we accumulate hydrogens, you take two hydrogens and combine it with oxygen, and we form water. Okay? But in doing so, you will get from cellular respiration between, well, it all depends on the book, as I've mentioned, 36 to 38 molecules of ATP per glucose. Per glucose molecule process. You see? Now that's the overview of cellular respiration. Remember all these activities that we've talked about. Membrane transport in chapter 3. All of it was totally related to the amount of ATP that you are able to produce. ATP, immediate form of energy. All right? Your patient's healing. They're going to heal through mitotic divisions. And that mitotic division requires ATP levels. You see? So, your mindset, whether it is or not, I don't know. I mean, ideally, I would be very successful if I can get you to begin to think this way. You look at that patient and you say, wow, all of these things are going to happen, and this is my job, this is what I've got to do. For example, if they're lying in bed because of a stroke or because of a coma, your first thoughts are, is that, my goodness gracious, muscle atrophy. The muscles are going to atrophy. The muscles are going to deteriorate. I think it's like 1% per day. So they're going to have time walking after 2 weeks in a coma. You see? And so, somewhere or another, I mean, if it's your kid, I would be in there moving the legs. And I've had personal experience. I don't know if I ever told. Did I tell you about that kid in the quarantine? No. This was very. I will never forget this one.